So this is question 5 on the spring 2025 CS61B midterm 1, consume and interleave. So we're given an exam deck interface and an exam array deck class, which behaves like a deck with an additional method, consume and interleave. So remember the deck had a couple different methods, um, add first, add last. We have toList, empty, size, remove first, remove last. And so the exam deck interface also will have all of these deck operations that we can use. We can also see that it needs a default consume and interleave method, which we're going to implement later. Looking at the exam deck class, we see that it implements the exam deck. Um, and so we're going to need to implement some of the methods in the following parts of the question. So the consume and interleave method within the exam deck interface receives as input an exam deck other, which is the same length as, but not equal to, the current exam deck. So we're going to receive another exam deck as an input, which is going to be the same length as our current exam deck, but it's not going to be exactly the same exam deck as our input. It interleaves other with the current exam deck without creating a new exam deck. So we are going to have to interleave these two exam decks together without initializing another exam deck for our output. Additionally, other should be empty after the call completes. So we shouldn't leave any items in other after our method is done running. For example, if we have exam deck X, 2, 3, 4, 5, 6, and Y, 20, 30, 40, 50, 60, after we call x.consume interleave Y, X should be the result of interleaving together. So we have the 2, then we bring in the 20, then we bring the 3, then we bring in the 30, and so on. So we are alternating between X and Y, and that should be stored in X. And then after calling consume interleave, Y should also, Y should be actually empty. So now we can move on to part A. A asks us to write a unit test that checks the correctness of consume and interleave. And we're given an example of how to use the contains exactly and is equal to methods in the truth library. So we need to write a test that makes sure that our method consume and interleave actually works. And so let's look at some of the lines that we have here. We have a test, and we have X equals new exam array, sorry, new array deck. And then we provide an input list of 2, 3, and 4. Just as a side note, there should be brackets here. That was a clarification in the exam. And so right here on this first line, we're just making a new exam array deck object, and we're putting that in X. And so we need to define the type of X, the type that X holds. And so if we look at exam array deck, we can see that it implements the exam deck interface. And so X will be of type exam deck. So we can just put exam deck. And we also need to know what what sort of values X holds. And you can see we're giving in integers 2, 3, and 4. And so when we initialize X, we need to make sure that the data type is an integer. So we're going to put this and put integer in here. And so this is pretty similar to just whenever we're declaring any something like a list, right? So we put the interface first, and then we put the variable name, and then we say exactly which type of list we're going to input. So this is a very similar way of doing this, similar to what we've done before. So now we have the line assert that x.toList contains exactly 2, 3, 4 in order. So this is just making sure that our exam array deck was initialized properly, and it's showing us how the contains exactly method is used. And then we assert that x is equal to this new exam deck, 2, 3, 4, and this is just showing us how the is equals to method is used. So now we actually have to write our test. And so we're going to have to actually interleave stuff in order to see whether our function works, right? And interleave takes in another exam deck that is not the exact same as the as X. And so we should define another exam deck that we can use to interleave and see whether our method actually works, right? So we can initialize another exam deck. We're going to have to use integer. We can call this other, and this will be a new exam. Sorry, put a space there. Array deck. And we need to provide some initial values in this new list. So we can do list dot of, and we can put in, let's say 5, 6, 7. And now that we've created our other exam array deck, we can call consume and interleave on these two. So let's call it X. Our method was called consume and interleave. And remember, we're going to provide other as the input. And so now that we've called consume and interleave, we actually need to check whether it worked. And so we need to check whether X, remember X had 2, 3, 4, and other had 5, 6, 7. So after this, X needs to be 2, 5, 3, 2, 5, 3, 6, 4, and 7. That's after mixing them together, after interleaving them. And then other should be an empty list, right? Because we remove all the items in there. So we need to check these two conditions. Let's first check X. So we can check that. Oops. We can check that by doing X. Sorry, we need to use the assert methods, right? Assert that. So we could do it in 2 ways. We could do contains exactly that in order, or we can do is equal to this. I'm just going to use the to list because it's smaller. X dot to list contains exactly, and now we need to provide the list. So it would be 2, 5, 3, 6, 4, 7, and then this needs to be in order. So this will check whether the interleave actually worked. And after that, we need to check whether Y is empty, right? So we need to assert that Y we can do is equal to here, just to show you guys. Is equal to new exam array deck. And we don't need to provide any input, right? Because we want to check whether Y is empty. And so we compare it with an empty array deck. Like this. And so this should check whether Y is empty. And that should be the two tests that we have. So this will make sure that our consume and interleave test actually works. And we don't need to add any more lines. So now moving on to part B, we need to fill in the consume and interleave method in the exam deck interface. And so this is actually the part where we need to implement the consume and interleave function. So just thinking about it conceptually, right? Let's say we have um, we have an exam deck X, and it has 1, 2, 3, and we have one Y that is 4, 5, 6. We want to interleave them together. So ideally, if we could just put like 4 right in between 2 and 3, um, that would make things really easy. But we don't have a way to insert items in the middle of our exam deck, right? The exam deck is a deck, so we can only interact with the front, the first item, and the last items. And so this method, this way of doing things isn't going to really work since we can't access the middle of the deck. And so we're going to have to think of a way to get all the items we need to the end. And so we can actually interact with them, right? And so ideally, we had all our items somewhere, you know, we had the 1, 2, 3 somewhere, and then we had the 4, 5, 6 somewhere, and X would be blank. And then we could just pick out the items that we need and put them into X. But we remember we can't create another exam deck based on the instructions in the problem. So we're going to have to store the items in X inside Y, right? Because we can't put them somewhere else. We can't create a new exam deck. So let's think about how we want to just temporarily store the items in X and Y so that we can retrieve them in the correct order inside X. Um, well, if we put the items like this, right? So if we have Y equals 4, 5, and 6, if we put in the items in X in reverse order, so we put in the last element right after, if we put in 3 and then 2 and then 1, so this is just taking the last item in X and repeatedly putting it in the last position in Y. Then you can see we have all our items stored in Y, and X will be empty at this point since we removed lasted. We did remove last 3 times. And so now we have all our items like stored in a buffer, and we can just retrieve them since all the items that we need are at the ends of the deck where we can actually retrieve the items. So we could just get last, or sorry, remove last, and that will give us the 1. And so X, let's do this. X will have the 1, we'll take the 1, put that in, right? The 1 is removed now. And then we can do remove first, that will give us the 4. And now we can do remove last again, that will give us the 2. Remove first, that will give us the 5. Remove last, give us the 3. Remove first, give us the 6. And so now after doing that set of operations, after just repeatedly doing remove last and remove first, we have all the items back in X, except now they're in interleaved order, right? So the main trick was just seeing that we could store the items in Y and then bring them back into X in the way that we want, right? So now we need to actually implement this idea in terms of code. So let me erase these. Um, so remember, we need to implement this idea now. So these first couple lines, just check whether the other deck that we're looking at is the same size as the current one. So we don't need to worry about if these two decks are of different sizes. So remember, the first thing we're going to do is we're going to take everything in X and put them into Y. So while X is not empty, right? We haven't remember we have a is empty method up here that we can use since it's in the exam deck interface. So while X is not empty, we want to transfer its items into Y to temporarily store, right? So then Y equals 4, 5, 6. So we want to take the last item in X and put that as the last item in Y. So we're going to do Y, sorry, not Y. We have to use other since that is the parameter that we're given. Other dot add last. And then we just remove the last item in X, right? So in this case, we don't have an X, right? We have a this. This dot remove last. So this will transfer all the items into Y. And now we need to transfer the items from Y back into X, given that X is empty. And then Y will have our items in the order 4, 5, 6, 3, 2, 1. So we can do while. Again, we have to check while, sorry. This should not be X. This should be, oops, this should be this. My bad. We have to do while other is not empty. We have to alternate between taking the last item in other and the first item and adding them to this, right? So we do, let's say we can do this dot add oops, add last other dot remove last. So this will take the 1 and then add it to X. And now we need to take the first one to get our pair. We need to do remove first here, right? And this will just go through Y, and remember it will alternate between removing the last, removing the first, and then adding that to X will give us the interleaved exam deck that we were looking for. And after this whole process, remember other is going to be empty. And so it satisfies both of our conditions. And so this would be the solution to this question. Also, it's important to note there are a couple different ways of doing this. This is just one of the ways that I thought was intuitive.